For 3.1, and this is actually day one, we should say, we are going to focus on vocabulary. Okay. The vocabulary in this section is very crucial as you move forward. It's definitely something that gets used constantly in Algebra 2, and you'll see it periodically throughout Algebra 1. So the first two things that I want to talk about are relations and functions. Okay, relation is pretty much anything that we're going to talk about here. So it's just a collection of data. Okay, so a collection, I'm going to say, of ordered pairs. So as long as you have x's and y's, you have this data set, you're going to have a relation, which is pretty much everything that you're going to see moving forward. Okay, now a function is different. Not everything is a function. So a function is a type of relation in which each input has exactly one output. Oops, sorry. Input. And again, it's exactly one output. Okay, so in other words, x's cannot repeat. Okay, so x values do not repeat. And you'll see that as we continue. Okay, so let's scroll down and let's talk about all of these, whether they're a relation or a function. Okay, so for this first example, okay, these are actually typically seen as like domain and range, which we'll talk about in a second. But is it a relation? Well, yes, okay, because relations are talking about points, and these are actually points. So if you notice this first one, that means -2, -3 is a point, and -2, 6 is a point, and so on and so on, okay? So in regards to a function, that -2 is repeating, which means it is not a function. Okay, again, anytime your inputs or your x values repeat, it is not a function. Okay, so let's look at that in the next one. Is it a relation? Well, yes, because it's a set of points, right? It's a graph, it's a relation. Again, everything that you have that you're going to see is pretty much always going to be a relation. Okay, it'll be painfully obvious if it's not. And you'll see that eventually, maybe. All right, so is this a function? Are there any x values that are going to repeat? Well, the x values are not going to repeat, so this is a function. And the way to check this is if you do a vertical line test. So if I have a vertical line and then I take it, I don't know how I want to do this. And then I take that, hold on, let me pull this up. Pretend that that's perfectly straight. But if I take it and I move it across the graph like this, it should only ever touch at one point at a time, which it would never touch it at 2 points. So because of that, it passes the vertical line test, which means that this is a function. Okay, I'm going to put this in tablet mode again. So then we get to the next one. This is just an XY chart. So if you look at the x's, there are no repeats, which means, yes, this is a function, right? And again, XY chart, meaning these are points, meaning this is a relation. Next one, we just have a whole bunch of points, which again means it is a relation. And then looking at whether it's a function or not. Okay, looking at our x values, we have 2, 3, 3, 2, which means actually multiple things are repeating. So this is not a function. Okay, so now that we've talked about relations and functions, we're going to talk about domain and range. Now, this is something that will be talked about so often moving forward, and especially with Algebra 2. So domain is the set of x values, and range is the set of y values. Okay, the number one rule, well, number 1 and 2, you go from least to greatest, with no repeating values. Okay, so if I have 5 2s, I'm only going to write 2 once. If I have a -1 and a -10, I'm going to put -10, -1, because it needs to go from least to greatest. So let's focus on domain and range for these ones. Okay, now anytime you have something like this, these are actually called relations. Okay, and domain is always the left and range is always the y. Okay, it's kind of just like an XY thing, like the chart that you see here. Okay, but it's domain and range. So that means that I can write in set notation my domain. So -2, 3, 4. It's in increasing order and there's no repeats. Same thing with range. We have -3, 6, 9. No repeats. It's in increasing order. Now on the next one, this you can write 2 different ways. Okay, if you notice, this is a line. Well, it's actually a function. It's a graph of an equation, right? We could see that. So we know these little arrows on the top and bottom mean that they go on infinitely, right? So that means that you're going to have all reals. Now I'm fine with you writing all reals. Otherwise, negative to positive infinity is fine. Either way is acceptable. For the next one, our domain are our x values, so 1, 3, 5, 7. And our range. This one is out of order and there's repeats, so we need to make sure that we write it out as 2, 4, 5. All right, increasing order, no repeats. Same thing with the last one. Our x values are 2 and 3, and our y values are -2 and 1. Okay, I don't need to write any repeats or it needs to be in increasing order. All right, so the next 2 things are talking about the graph itself. So the domain of a function is continuous when it includes all real numbers. The graph of a function is a line or a curve. The domain of a function is discrete when it consists of just whole numbers or integers. The graph of a function is typically just data points. Okay, so discrete or continuous. So if we look at the first one, okay, this is just a whole bunch of points, right? So anytime you have domain and range like that in a relation, this will be discrete. On the next one, we are talking about all real numbers. We're talking about a graph. It's a line. Well, it's actually not a line, but you know what I'm saying. So this is when it's continuous. Whereas on the next 2, these are all just points. If we were to graph them, we wouldn't have a line, we wouldn't have like an equation, nothing. It would just be points. So that's where it's discrete. And our last vocab to talk about is when a function is 1 to 1. And I'll write it like this often. Kind of looks like a face. But if no 2 elements on the domain map to the same element in the range. When 2 or more elements of the domain map to the same element of the range, the function is not 1 to 1. So essentially it is 1 to 1 when there are no y values repeating. Okay, so it's a function if no x's repeat, it's 1 to 1 if no y's repeat. So if we look at the next one, okay, in order to be 1 to 1, you have to be a function. So the fact that it is not a function automatically means no, okay? Now, that's coming from the fact that this 6 is repeating, okay? So 6 is repeating. No, it's not 1 to 1. And the next one, it is 1 to 1 because there are going to be no y values repeating. Essentially, what you could do is the horizontal line test for this one if you wanted to think about it that way. But it's pretty obvious, no y's are repeating. On the next one, we have 2 4s. So because we have 2 4s, this is a no, it is not 1 to 1. And on the next one, we have 2 1s and 2 -2s, which means it is also not 1-to-1. So this is the main idea from today. So we're just going to work with that a little bit longer, and then it'll be time for your Kahoot for homework. So it says identify the domain and range of the function. So again, domain are your x values. So I'm focusing on the top part of this graph. So in set notation, from least to greatest, 1, 2, 3, 4, 5. My range is talking about the bottom, and from least to greatest would be 11, 12, and 13. Notice how I did not write 13 3 times because we do not write any repeating numbers. For the next one, your domain, we still want to focus on our x values. So what I do is I always start farthest left and then work my way to the right, just focusing on my x values. So the farthest left I have is -4 right here. Then I move over and I have these two at -2. But again, I don't need to repeat, so I just need to write it once. Next dot is at -1. Then I have 2 at 3, but I just write it one time. So now I'm going to do the same thing, except I start from the bottom and work my way up for my range. So my lowest y value would be at -2 with these 2 dots. Then I'm up at 0 with that dot, 1 for those two, and 2 for that one. So that is my range. Again, least to greatest, no repeats. The next part just talks about, is the relation a function? If it is it 1-to-1? Again, it has to be a function in order to be 1-to-1. And then is it discrete or continuous? So on this one, remember, in order to be a function, the x's cannot repeat. So if we look at these, 1, 5, 7, 8, no x's are repeating, so yes, it is a function. This would be discrete because it is just a set of points. And it is 1-to-1 because in order to be 1-to-1, y's cannot repeat. And we have 2, 6, -1, 0, no repeats, which means it's 1-to-1. I encourage you to try the next 3 before you watch me do them and see if you can get them right. So go ahead and pause the video and then we'll get started. So for part B, this one is not a function because of the fact that it repeats are 3. Now, technically, yes, it is 1-to-1 because of the fact that there are no y's repeating, but no, it's not really 1-to-1 because the function is not a function. I'm really okay with either one. I'll clarify a little bit more tomorrow on that aspect, okay? But again, this is discrete for sure because it's just a set of points. On the next one, this is a function. Anytime that you have a graph like this that's a straight line, lines are functions. And it is continuous because it is something that is going to include all real numbers. Anytime you have a graph of a line, it's going to be continuous. And yes, this is 1-to-1 because there will be no y values that get repeated. On this last one, this is a function because there are no x values repeating. It's discrete because it's a set of points. It is not 1-to-1 because this 17 and the 10 are repeating for your y values. And then our domain and range. Domain would be 1, 2, 3, 4, 5. Range, again, increasing order, no repeats, 10, 11, 17.